Good afternoon, esteemed judge. We are going to present scientific project, mathematical and computer modeling of mechanical processes. The goal of the work to create mathematical and computational models of material bodies that generate motion in physical processes, taking into account the fundamental laws of nature. Research object reinforced vibrations of a disk and a plate with 2 degrees of freedom connected by an elastic link. The novelty of the work: mathematical models of vibrations of system with a mechanical degree of 2 was developed, and their solution methods were defined.
First, oscillation of a material point. When a material point is subjected to a restoring force and periodically varying external forces, it performs forced oscillation. His differential formula is m multiplied the second order derivative x equal minus p plus q of x. Here k is frequency of forced oscillation and h is amplitude. Here is independent solution and general solution. When we explore forced oscillation, we were interested in 3 models. The first model is the phase of forced oscillation. There are 2 types of phase of forced oscillation. The first model, when k more than b. In this case, the amplitude is equal h divided k squared minus b squared, and phase of oscillation is the phase of deflection force because it's same, doesn't change. The second model, when p more than k, point angle displaced in the direction opposite to the direction of force q. The second moment we were interested in amplitude of force oscillation. The formula founded by amplitude of force oscillation is this, and theta is a device of amplitude. And if k more than b, theta founded by next form, and if p more than k, theta founded by the next form. The third moment we were interested in phenomena of resonance. When p divide k south 1 and theta south infinity, it makes a phenomenon of resonance.
Study of the free and forced oscillation of a disk with an elastic connection took place. Here is the parameters of the test and system outline, modified system outline. To build a mathematical model of dynamical system, we used Lagrange equation of the second kind. The calculation results for the potential and kinetic energy are denoted as T and P. By calculating the derivatives and substituting them into the Lagrange equation, the differential equation of oscillation for the system under the consideration is obtained, and this leads us to the next independent solution of the differential equation.
Using this program while we were studying forced oscillation. When the program is activated, we can observe that the oscillation occurs only in the horizontal direction with specific periods. Additional information can be found in the data table, and each body has its own velocity graph, graph 1, graph 2, and graph 3. And these graphs were generated based on the differential equation mentioned above, graph 1, graph 2, and graph 3. And if you change speed, you can see the periods of forced oscillation decreased.
In conclusion, considering the use of free and forced oscillation of the dynamic system, we used Lagrange equation of the second kind for our calculation. Relationships between amplitudes and frequencies of oscillation, which are the main parameters of the system, are given, and the phenomenon of resonance in the system was fully analyzed. The results of the work can be used in the design of mechanical structures with 2 degrees of freedom.